All right, so when I gave you this, and when we talked about it the first day, I told you that for tangent, there is more than just this one option, but I felt like this one option was enough, and then I sort of changed my mind. You get the same answer, no matter which ones you use, but sometimes the other options for tangent are easier, so you should have some room down here at the bottom, and we're just going to write the other two tangent options on here so that you have them, okay? And so we have tangent, it'll be tangent of theta over 2 equals 1 minus cosine theta over sine theta. And then there's also tangent of theta over 2 equals sine theta over 1 plus cosine theta. Okay, so those are just two other options to use when you substitute. Because when you're using it as an identity to like prove the identities or even to substitute, sometimes it's nicer not to have that square root. The value would be the same if you're using numbers though. Okay, and then keep this handy and be able to flip back and forth from this to the green one as well, because we're going to need both of those today. All right. So just kind of mark them with your page and flip back and forth so you can get them. I'm also thinking I should have put them all on one, but you know, hindsight's 20/20. All right, so then what we're doing today is going on page 122. We are still solving these trig equations. Yesterday we solved them basically just using algebra solving skills and factoring skills that we already have. And today we're going to use those same skills plus some identities. Because if we look at number 1 here, and it is a quadratic, if I put it all equal to 0, well then I'm going to have sine and cosine mixed. I'm not going to be able to factor it. So you can substitute using some of your identities. Now, when you substitute for cosine, the only thing you really have is to make that 1 over secant. I don't know if that's going to help me any. But sine squared is part of a Pythagorean identity, so I think I could probably substitute something in there. Does that make sense? So I'm going to leave the left-hand side or I'm just going to rewrite this part rather. So I'm going to get cosine x minus 1 equals, and then what would I substitute in for sine squared? 1 minus cosine squared. So now it's just all in terms of cosine, and basically we are where we started yesterday. So I'm going to put them all to the left-hand side so I can make that squared positive. So I get cosine squared x plus cosine x. And is it just equal to 0 then? Yeah, I got to subtract 1. Minus 2 equals 0. Okay? All right, so then I can factor this, right? I'm going to factor this into two binomials. So I know that this is cosine x and cosine x. And then that's a 2, so it has to be a 1 and a 2. And then the signs have to be different. Which one is positive? The 2. Okay? So plus 2 and minus 1. So now I can solve this, set them both equal to 0, which means that I get cosine of x equals 1 and cosine of x equals negative 2. And I'm going from negative infinity to infinity, which means I'm using the entire circle, and then I'm going to have some repeats, right? So when on the circle is cosine 1? At 0 and where? Pi? It's okay. And then, it's just 0, right? And then, where is cosine negative 2? It's not, right? Because this is less than negative 1. Like, that doesn't work at all. It doesn't make any sense. Okay, and then since I go from negative infinity to infinity, I have to add 2 pi n to that. So I get x equals 0 plus 2 pi n. Do I even need the 0? Well, no, because 0 plus 2 pi n is just 2 pi n, right? But it doesn't matter. We can leave it. I'm not going to rewrite it. It's the same thing, but 0 doesn't have to be there. Everybody okay with that? Okay. So then let's look at number 2. I've got cotangent squared minus 3 cosecant squared, minus 3 cosecant theta plus 3. I could make cotangent into cosine over sine, and cosecant into 1 over sine, and then I've got common denominators, but I don't think that's really where I want to go with this, right? As far as the Pythagorean identities go, what does cotangent match up with in the little equation? What does it say on your green one? Yeah. So cosecant squared plus 1, I'm sorry, cotangent squared plus 1 equals cosecant squared, right? So if I want to substitute for cotangent squared, what do I substitute in there for that? Good. Cosecant squared theta minus 1 minus 3 cosecant theta plus 3 equals 0. Okay. And if you're just staring at me and not even looking at the green one, it's going to be hard for you to know what to find. Okay, you don't even have yours out. Where's yours? Some of y'all don't even have a green one handy. And then we whine and complain because we're confused and don't know what we're doing. Okay, so then I get cosecant squared theta minus 3 cosecant theta plus 2 equals 0. Easy to factor. So I get cosecant theta and cosecant theta. This is a 2 and a 1. And the signs have to be the same. This is negative, so they both have to be negative. Now I can solve this. So I get cosecant theta equals 2 and cosecant theta equals 1. And I don't really want cosecant. What do I want to make that into? Sine. Okay, so this is going to be sine theta equals 1/2 and sine theta equals 1. Right. My interval goes from 0 to 2 pi, so I'm using the whole circle, but there's no repeats this time. So when is sine a positive 1/2? At pi 6. Good. And 5 pi 6. Good, because it's in quadrants 1 and 2. When is sine 1? At pi halves. Good. Okay. So those are my 3 answers. Now I just have to put them in order. So theta is equal to pi 6, pi halves, and 5 pi 6. Any questions at all? Okay. So let's look at number 3. I need to be able to, factor something out or solve something. And if I'm going to just solve it without factoring, then the two things have to match. Otherwise, I have to be able to factor things out. I got nothing to factor here. Got nothing I can do. But I can make tangent into sine over cosine. So let's start there and see what happens. So we're going to get 3 times the sine of alpha over the cosine of alpha minus 2 square root of 3 times the sine of alpha equals 0. So, could I get a common denominator here? Yes. Do I have any other options besides that? Could I factor out? Do I have a GCF? Yeah, what is it? Sine of alpha. So let's just factor instead of making things worse, right? So sine of alpha gets factored out. That leaves me with 3 times 1 over cosine alpha minus 2 square root of 3 equals 0. Everybody good with all that? Okay, now, what is 1 over cosine? Secant. So I could have just put secant here. I just didn't want to lose anybody. I could skip that step and just go straight to secant, and it's fine. So I have sine of alpha times 3 secant alpha minus 2 square root of 3 equals 0. So now I have it factored, so at least the sine and the secant, even though they're different, it's fine because I can split them differently. There's 2 different factors here. So now sine of alpha equals 0, and secant alpha equals 2 square root of 3 over 3. Can I cancel those 3's out? No. But I don't really want secant. I want to make that cosine. So that's going to be 3 over 2 square root of 3, which is 3 square root of 3 over 6, which is a square root of 3 over 2. Bless you. So now I have sine of alpha equals something and cosine of alpha equals something. I go look at my interval, which is going from pi to 2 pi. So using this part of the circle. So for this, when is sine 0? Pi and 2 pi. And when is cosine square root of 3 over 2? 11 pi 6. That's because it's going to be in the fourth quadrant only, so I get 11 pi 6. So these are my two sets of answers. So alpha is equal to pi, 11 pi 6ths, and 2 pi. Any questions at all? All right. Let's look at the next one. I think we just need to work through here. All right, so I have secant of x minus tangent of x equals 1. Okay, so let's just think about our options here. I could make secant 1 over cosine, and I could make tangent sine over cosine, which would actually give me a common denominator, but I don't know that I would get anywhere. And I don't know that you're always going to think about all those things. Like sometimes you figure that out after you have substituted a bunch of stuff, and then you get to a point where you can't get anywhere, right? And then you have to start over. So that may happen to you, and that's okay. So, and if we did that, if we made secant into 1 over cosine and tangent into sine over cosine, we'd end up with 1 minus sine over cosine. I still can't get anywhere with that, right? And again, you may not recognize that until you're like halfway through something. But then let's think about how else is secant and tangent related. Look on your little chart. Where do you see secant and tangent that are related to each other? The secant and tangent of any sort. So what, the Pythagorean identities, right? The problem is these aren't squared, right? But if you try the other stuff and you can't get anywhere and you're like, but they're related there, so maybe I can use this somehow. I definitely don't want to leave them together like this, but if I move tangent over, look what I can do. I've got secant of x equals tangent x plus 1. So, I mean, it's okay to have two different, like I have a sine and a secant here. It's okay to have two different things as long as you can factor something out, or sometimes it's nice to have them all the same. Well, if that was secant squared, then I could get tangent squared out of it, right? Can I make that secant squared? Yes, and whatever I do to one side, I have to do to the other, right? So I'm going to square both sides. On the left, I get secant squared x. On the right, do I get tangent squared x plus 1? No, I do not. I get tangent squared x plus 2 tangent x plus 1. Okay, so my whole thought behind that was now that secant can get me some tangent stuff, right? But, so when I substitute in for secant, what actually gets substituted there? Good. Tangent squared x plus 1 equals tangent squared x plus 2 tangent x plus 1. Everybody with me so far? So I can start by subtracting tangent squared from both sides. That leaves me with 1 equals 2 tangent x plus 1. Then I can subtract 1 from both sides, and I get 0 equals 2 tangent x. Then I can divide both sides by 2, and I get 0 equals tangent x. I'm going from 0 to 2 pi, which is the whole circle. When is tangent 0? It's 0. And where else? Pi and 2 pi. And even though 0 and 2 pi are in the same spot, your interval goes from 0 to 2 pi inclusively, so you have to use both of them. It is both of them. Any questions at all? Because whatever you do to one side, you can do to the other. It's just like taking the square root of both sides. As long as you keep the equation balanced, you can do whatever you want. I could have added 5 to both sides for no apparent reason, like just because. As long as it stays equal, I can do whatever I want. Does that make sense? Okay, that's a good question. Anything else? All right. Well, let's look at the back. All right, so now I have sine of 2u plus 4 cosine u equals 3 cosine u. So I'm thinking the first thing I want to do is get rid of that double angle. So make sure when you are rewriting stuff that you are keeping up with your 2's and your squareds and you have all those in the right spot and you're not making stuff up along the way, because it's pretty easy to make stuff up sometimes. But that sine of 2u, if you look at that little yellow sheet, you don't have many, there's only one option there, so that becomes 2 sine u cosine u plus 4 cosine u equals 3 cosine u. Everybody with me? So now I need to set it equal to 0. So this gives me 2 sine u cosine u. Then what? Plus cosine u equals 0. So what can I do here? I can factor, right? I got a GCF. So my cosine u can factor out. That leaves me with 2 sine u plus 1 equals 0. Now I got it factored. I can set each factor equal to 0. So cosine u equals 0 and sine u equals negative 1/2. Going from 0 to 2 pi, so I'm using the whole circle, no repeats. When is cosine 0? Pi halves and 3 pi halves. And when is sine negative 1/2? Good. 7 pi 6 and 11 pi 6, because that's down in the third and fourth quadrants. Right? So now I put them in order. That's going to give me pi halves, 7 pi 6ths, 3 pi halves, and 11 pi 6ths. Any questions? Okay. Let's look at the next one. So I have cotangent of 2 theta plus 2 tangent of theta plus 2 equals 0. So I don't have a cotangent of 2 theta. And I'd really like to just get everything in sine and cosine anyway. So just like if that was cotangent squared, I could put cosine squared over sine squared. So this is cotangent 2 theta. I can make this into cosine 2 theta over sine 2 theta times 2, and then that tangent theta, I'm going to make it into sine theta over cosine theta plus 2 equals 0. Also make sure you're paying attention to when you have addition and multiplication, and so you're not trying to do like the wrong things at the wrong time, like try and get a common denominator with these first 2 fractions or something weird. Now I need to get rid of these 2 theta things, right? So for cosine, I have 3 options. I'm going to hold off on the options for right now, and let's go ahead and substitute in the sine of 2 theta because you don't have options there. This is 2 sine theta cosine theta times, this is 2 sine theta over cosine theta plus 2 equals 0. So before I ever even put the numerator in there, do you see some stuff that can happen here? What can I do with those 2's? These 2's. These cancel out, right? What happens with the sines? They cancel out also. So I'm just left with cosine in the denominator. So no matter which one of the cosine 2 thetas I substitute in, we'll get the same answer in the end. But if I just have cosine in the denominator, which one of those 3 would make the most sense? I mean, again, it's a matter of opinion, but if you look at the third one only has cosines in it, right? Now, it's not wrong to use the other ones. You'll eventually get there. It may not even be more work, but I'm going to go with the third one because there's only cosines in there. And you may not always have enough information to make a really good educated guess on that, and you just pick one, okay? That's what I'm substituting in there for the cosine 2 theta. You with me? All right, so now I'm going to actually multiply those 2 fractions together. So in the numerator, the second one, I just have 1 now. So I end up with 2 cosine squared theta minus 1 over what? Cosine squared theta. Good. Plus 2 equals 0. So I could get a common denominator here, but what's another option? What else could you do with it? Split it. So I'm going to make this into 2 cosine squared theta over cosine squared theta minus 1 over cosine squared theta plus 2 equals 0. So what happens with that first fraction? Yep, those cancel out. You're just left with 2. Minus, what's 1 over cosine? Secant squared theta, good, plus 2 equals 0. So that means I get 4 minus secant squared theta equals 0. So this is a difference of 2 squares, but I can also just solve it and get 4 equals secant squared theta, which means that secant theta equals what? Plus or minus 2, and you cannot forget the plus or minus, right? But then I don't really want secant. What do I want? Cosine. So I get cosine theta is equal to plus or minus 1/2. So then I'm looking for, where are we going? Pi halves to 3 pi halves. So pi halves to 3 pi halves is quadrants 2 and 3. So cosine inverse of 1/2 is pi thirds. So basically I want my pi thirds angle in both of these quadrants. What's the second quadrant pi thirds angle? 2 pi thirds. And then my third quadrant is 4 pi thirds. Everybody good with that? Any questions at all? Okay. Let's look at these half angles. I have cosine of x plus 2 equals sine of x over 2. Okay, so I want to get rid of that half angle. So on your little yellow sheet, you only have one option for sine of theta over 2. So we'll substitute that in. We get cosine of x plus 2 equals plus or minus the square root of 1 minus cosine x over 2. Everybody with me? What will be the first thing you'd like to get rid of? The square root. So how do we do that? Square both sides. So we're going to square both sides. And this, on the left-hand side, when I square this, I'm going to get cosine squared x plus 4 cosine x plus 4 equals, and then over here, I am just left with 1 minus cosine x over 2. Everybody with me? All right, so what would be the next thing we'd like to get rid of? The 2. And when you multiply both sides, make sure on the left you multiply every single term. So you're going to get 2 cosine squared x plus 8 cosine x plus 8 equals 1 minus cosine x. Yes? Then set it equal to 0. So we get 2 cosine squared x plus 9 cosine x plus 7 equals 0. So we are factoring. A is not 1, but when A is a prime number and C is a prime number, it's really not that crazy hard to do. So let's look at how we can reason through this pretty quickly, because we got to be able to factor stuff like this quick. This is 2 cosine x and cosine x. Those are my only options for the beginning. Then since this is positive, the signs have to be the same, and since this is positive, they're both plus. Okay? And since that's a 7, I put a 7 and a 1 in. Well, if I put the 7 here, I'm going to get 2 times 7, which is 14, and that makes no sense to get me to 9, because I'm not subtracting anything. So this would have to be a 1, and this would have to be a 7. 2 times 1 is 2, 7 times 1 is 7. Together that gives me 9. Bam, you just checked yourself. And 7 times 1 is 7. So make sure after you factor, you always check that it's going to work. Okay? But you got to be able to factor quickly and accurately. So now we have cosine of x is equal to negative 7/2, and cosine of x is equal to negative 1. I'm going to look at my interval here. I'm going from 0 to 2 pi. That's a whole circle, no repeats. So when does cosine give me a negative 7/2? Never, because that is less than negative 1, so this is just doesn't work. When is cosine negative 1? At pi. And your answer is x equals pi. Questions? All right. So let's look at the last one. So I've got two half angles here. Well, this one is squared, which means whatever the cosine of theta over 2 is, that thing gets squared. So your cosine of your half angle has a square root on it. But since it's squared, what happens to the square root? It goes away. Okay? So we're not going to have to worry about that. And we don't have options for that one anyway, right? And then tangent, we do have a few options. That one's not squared. So I'm thinking we don't want to pick the one that was printed on here. That's why I gave you some other ones, because it has a square root on it and it's not going to go away. So I gave you two other ones. One has two terms in the numerator and one has two terms in the denominator. Where would you rather have the two terms? In the numerator, for sure, right? I mean, that's just maybe that's not even the best trig function to put in there, but it's definitely easier to deal with the fraction that way. You agree? So that's just kind of how you think through. Let me try this one, right? So we'll put 1/2. Instead of tangent of a over 2, we'll use the one where we just have the sine in the denominator. So it's going to be times 1 minus cosine a over sine a. Minus, and that's cosine squared. That's why we're not using the root here. Like, we don't have to write it in and then show that it's gone. We'll just be left with 1 plus cosine a, bless you, over 2 times cosecant is 1 over what? Sine. Oh, and look at that. We got sines in the denominator. Equals 1. So let's just clean up each of the separate fractions. The first one's going to give me 1 minus cosine a over 2 sine a minus 1 plus cosine a over 2 sine a equals 1. So in the numerator, am I going to multiply the difference of squares? I'm subtracting, I'm not multiplying, right? Don't go making stuff up. Right? But I do already have a common denominator, so that's nice. And my common denominator is 2 sine a. It's going to equal 1. So do my numerators just completely zero out? No. 1 minus 1 does zero out. But then what am I left with in the numerator? Good. Negative 2 cosine a. Okay, you got to subtract both of those things in that numerator. You can pretend like there's parentheses here if that helps. Okay, but that's where that comes from. All right, so can I reduce a little bit? Yeah, the 2's cancel out, right? And what's cosine over sine? Cotangent. So this is negative cotangent a equals 1, which means a positive cotangent a equals negative 1. But tangent is what I'm more familiar with, so what would tangent a be? Negative 1, because the reciprocal of negative 1 is negative 1, right? Then I'm got to look at my interval. I'm going from pi to 2 pi, so these two quadrants. Which of these two quadrants has tangent negative? Just the fourth, right? Because tangent's positive here. So fourth quadrant, tangent of a gives you negative 1. What is a? 7 pi over 4. And we're done. Okay. Questions? Anything? Okay. There's extra green and yellow sheets. There's not very many more green ones, but I can print some more if I need to. If you need them to keep them like separate out of your ISN, like I want them in there too, so you'll have them once you've lost those. But if you want an extra copy of them, you can have that too. And remember, your quiz is Thursday because I didn't want to rush it at this point. We'll probably had enough time in this class, but.